So hi friends, it's me Darshan Khaire, a student of KBT College of Engineering Nasik, currently studying in the second year of BTech Electrical Engineering. Today I am going to present my presentation on the topic of block diagram and operation of the digital frequency meter. So first of all, we will understand what is digital frequency meter. Here, the digital frequency meters represent a significant advancement over analog methods, offering higher accuracy, stability, and ease of reading for critical applications in electronics and telecommunications. So here, the frequency defined as the number of cycles of periodic phenomenon per second is a fundamental parameter in electrical engineering, telecommunications, and physics. Precise measurement of frequency is crucial for system calibration, validation, and control. So here as given, for the communication system, accurate frequency is essential for signal modulation, carrier wave generation, and ensuring reliable data transmission across various channels. And the examples are radio, mobile networks, etc. So in power systems, maintaining the standard frequency of 50 or 60 Hz is vital for the stability and synchronization of the electrical grid. Frequency meters are used to monitor and regulate grid performance. For instrumentation and control, many sensors and transducers convert physical quantity like speed, flow, or temperature into proportional frequencies. Measuring this frequency allows to accurate quantification of the original data. So here there is some basic principle for converting frequency to a count. First of all, there is an unknown signal and then the fixed time window, pulse counting and frequency calculation. And the key blocks for input conditioning and gating circuitry. Before signal can counted, it must be properly prepared. The input signal, which may be noisy or distorted, it firstly conditioned and then precisely regulated by the gating mechanism. First, input amplified. The signal is first passed through an input amplifier to boost weak signals for an attenuator to handle high amplitude signals, ensuring the signal level is appropriate for the following stages. And then schemic trigger. This is the critical stage for conditioning. The main gate, here the gate is typically an AND gate. Here the AND gate is used and then controlled by the time base. It selectively allows the conditioner input pulses to pass through to the counter only during the precise predetermined time interval, which is denoted as T. Here is a block diagram. So here the digital frequency meter architecture consists of several interconnected function blocks working in synchronization to achieve accurate frequency measurement. First, input signal, then amplifier, schemate, trigger, and main gate. Here the time-based generator and the heartbeat of accuracy. The accuracy of the frequency meter depends almost entirely on the stability and precision of the time-based generator. In short, TBG. The TBG provides the precise timing window. Here, the counter and latch circuit. These digital circuits are responsible for accumulating the input pulses passed through the main gate holding the data for display. The counter, a series of cascaded BCD, that is binary coded decimal counters, accumulates the pulses during the gating period. The latch. Immediately after the counting period ends, a latch circuit receives a signal to store the final count. Reset mechanism. Once the count is latched, a reset pulse clears the counter back to a zero, preparing it to begin counting the cycles of the measurement intervals. Then there is a display unit. In here, visualization of the measurement. So the display unit takes the binary coded output from the latch and converts it into human readable decimal format. And the modern meters use high brightness energy efficient displays. The use of digital display ensures an ambiguous reading, contributing significantly to the meter's ease of use and reduce operator application and advantages of digital frequency meter. The digital frequency meter have become the indispensable tools across multiple engineering disciplines due to their superior performance characteristics. Key advantages are high accuracy, wide frequency range, and digital readout. Thank you. I hope you like my presentation.